This video is going to cover Unit 22, Section 4, the Pythagorean Theorem. Okay, so the Pythagorean Theorem deals with specifically sides of a right triangle. I switched to my thicker Sharpie. I want to see if it stands out better. So we've got a right triangle here. Okay, and the Pythagorean Theorem states that a squared plus b squared equals c squared. So a squared plus b squared equals c squared. Now, c is the angle that is opposite of the 90 degree, always. C will always be the one that is opposite the 90 degrees. That is also called the hypotenuse. The hypotenuse is opposite of the 90 degree angle. The other two sides actually could be, this one could be B just as well, and this one could be A. It doesn't really matter. But C, the hypotenuse, will always be opposite the 90 degree angle. Okay, so let's talk about the 3, 4, 5 triangle. So let's say that this side is 3, this side is 4, and then this side would be 5. So 3 squared plus 4 squared is equal to 5 squared. Well, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Is this true? 9 plus 16 is equal to 25. Yep, the 3, 4, 5 triangle. So, the hypotenuse, if we're looking to find the hypotenuse and we have the other two sides, we can rearrange this equation right here to find the hypotenuse. So, if I wanted to find C, I would have to take the square root of that side. So therefore, I would have to take the square root of this side. So let's maintain this 3, 4, 5 triangle. So we know that my answer should be 5 if I'm trying to find the hypotenuse. So I will say C is equal to 3 squared plus 4 squared, and then take the square root of that. All right, so once again, we have C is equal to, let's just shortcut this and say the square root of 25, because we've got 9 plus 16 is going to be 25. The square root of 25 is 5, so I would say C is equal to 5. Now, I already knew this, but my purpose for doing this was to prove it to myself that this equation works, because I know that that should be 5. So let's take a look at another example. So let's find, my right triangles are not quite perfect. Okay, so let's say this side right here is 4, and this side is 7. And we need to find the hypotenuse. So we say C is equal to 4 squared plus 7 squared. Okay, so 4 squared is 16, 7 squared is 49. Take the square root of that. So we will have, see here, 65. So we have C is equal to the square root of 65. So let's see, where's my square root symbol? Square root 65 equals 8.06. Now, sometimes I would want to leave it just like that right there. except we would want to pull out even square roots. Now that's not part of this class, pulling out even square roots. Pulling out even square roots is exactly the same thing as reducing fractions. You would never write the answer of a fraction as, say, like 4/16. You would always reduce this to 1/4. Okay? And that's exactly the same thing that you do when you pull out even square roots, if there are any to pull out. But that's not part of this class. So generally speaking, instead of leaving it in what we would call the exact answer, we would go ahead and estimate it to be 8.06 in this case. All right? So let me erase this and, okay, erased it, clean sheet. Now, the Pythagorean theorem. Let's rewrite that as c squared is equal to a squared plus b squared. So if we're solving for c, we say c is equal to a squared plus b squared, and then the square root of that. Well, what if we wanted to find one of the other legs? So let's algebraically solve this for b. All right? So we would say c squared minus a squared equals b squared. All right? So I want b, not b squared, so I take the square root of that, and I take the square root of that. So I get b is equal to c squared minus a squared, and then the square root of it. Well, what if I'm looking for a? So over here, I'm going to algebraically solve this for a. So I will have c squared minus b squared is equal to a squared. And then once again, I need to take the square root of that. So I get a is equal to c squared minus b squared. Now, these two right here are really the same thing, remember, because I said a and b can be switched around. Okay? But these are generally your three equations for finding any of the three sides. Now, let's examine what's underneath the radical here. So we've got a minus right here. So if you accidentally subtract the wrong number, so if you accidentally subtract, say, b squared minus c squared in here, you're going to get a negative number under here, because the hypotenuse has to be longer than both of the sides. Otherwise, it wouldn't be a triangle. So c squared will always be bigger than either a squared or b squared. So if you subtract a larger number from a smaller number, you're going to get a negative underneath the radical, and your calculator is going to tell you you did something wrong. It's going to give you an error because you cannot have a negative underneath the radical. Well, you can, but not in this class. You can't have a negative under the radical. That's when you get into complex numbers and stuff like that. Okay, so let's do an example of one of these two types. Let's say we've got a hypotenuse, or a triangle with a hypotenuse here. Square right there, and let's say the hypotenuse is, let's just say 17, and this is 7. 7's good. I like 7s. So, and then this we'll call it, really doesn't matter, but I'm going to go ahead and be consistent with what I'm doing. We'll call it A. So we're looking for this one right here. All right? So A is equal to 17 squared minus 7 squared, and then the square root of that. Now, you can take care of that right in your calculator if you understand how to use it. So let me go ahead and zoom in right here on my calculator. Can I get it? My square is right there. Okay. So what I do is I'm going to go ahead and hit my square root symbol right there. And then I will say 17, And then my square button is right there. Can't see it, it's just off the film. Minus, and I know that 7 squared is 49, so I'll just put 49 in there. You could put 7 squared, it'll be the same thing. And then hit equals, and my calculator will automatically pull out the even square roots. It's something that it does automatically, but I can change it to a decimal by hitting a button that you can just right down here. Okay, so this would be 15.49. So that means that A is equal to 15.49. So this is not not proportional. So A is actually bigger than the other side. So I didn't draw this triangle proportionally correct, because this side is bigger than that one, and the way it looks, this side's bigger than that one. But, you know, that sometimes happens in math. Okay, so let's go ahead and do something. Let's see, what do they have here? 2 sides. All right, let's take a look at, so let's look at 573, page 573. And there's a table right there, well, figure 22-5, and it's got several different problems there, 7 through 12, where you have to find various sides. So side C, remember, side C is always going to be the hypotenuse. Side A and B are just the other legs. So let's take a look at number 9. I don't really even need to see the triangle here. I can say that side B is equal to C squared, which is, what did I say, number 9? Which is 30 squared minus A squared, which is 18 squared. Just check and make sure the units are right. Okay, so the square root of that. So I don't know off the top of my head what 30 squared and 18 squared are. So in my calculator, I will go ahead and say the square root of 30 squared minus 18 squared. And it's 24. Even 24. So B in this case is 24. Now, these all really form in the same manner. They're all pretty much done the same way. Let's take a look at let's take a look at number 20. Number 20 looks really complicated. What I'm going to do is I'm going to see if I can get it under here and zoom. Number 20. This one is fun. Oh, I almost can't move it that way far enough. All right. So our goal here is to find y and x. Now, let's be sure and be clear on exactly what y and x are. All right? Y is this side length right here. Or it looks like it's going to be the hypotenuse. X is this side from here to here. Okay, you see how it's the length from here to here, which is going to be this side right here is parallel to X. Y is parallel to this line right here, which is going to be the hypotenuse. And I'm going to need to write, I don't want to write on the book, so I will go ahead and erase that one paper, come up with this one. Okay, So trying to recreate this figure quickly here. All right. Let's draw. First I want to draw this part. And then out. And then down. There. Perfect. We got a 90 here. We got a 90 there. We've got 124 here. 60 right there. 90. And the distance from here to there is 50. And this one over here is 50. All right, we have to use our imagination a little bit. That doesn't even look close to 90, but it's supposed to be 90. All right, now, y, remember, is this hypotenuse, so I'm going to go ahead and say that this is y right there. And x is the distance from here to here, so I'll just write, I'll just go ahead and write it up here. Just to keep it out of the way down there. Okay. So we need to find the distance from here to here. And if I find this distance right here, I can add it to 50, and that will give me x. Okay? Because these two, this is a reflection of this side right here. X is. So how do I find this from here to here? Well, here's a right triangle. You gotta kind of look at it one piece at a time. There's a right triangle right there, and this is the hypotenuse of that triangle. And here is A and B. So the hypotenuse C is equal to 60 squared plus 124 squared, and then take the square root of that. So let's take care of that. So the square root of 60 squared plus 124 squared is equal to, okay, let's see here, 137.75. I'll leave it right at that. I'll use the other Sharpie because I think it shows up a little better. 137.75. It's just thicker. I can't write as neatly, as finely. Okay, so that means that x is going to be 137.75 plus this 50 right here to give me 187.75. So that's x. Now we need to find y. Well, let's take a look at what we've got here. What if I drew a line parallel to this one from this point over to here? Right to right there. Okay? So this line is parallel to that one. So that means that if this angle is 90, that this angle here is also 90. These are corresponding sides. So parallel lines cut by a transversal. These two angles right here are corresponding angles. So this is a 90-degree angle. Okay, so now we have, right here, we have a 90-degree triangle. So we can use the Pythagorean theorem on this. So that means that this side plus this side squared plus this side squared, and then we take the square root of that and we can get y. So we're using this same equation up here. Well, what is this side from here to here? Well, that's the same as x. So this side is 187.75, okay? Because it's the same distance from here to here as it is from here to here. Well, what about this side right here? How do we find that one? You may already see it. If I were, well, there's a couple different ways to look at this. This side from here to here is 90. Well, I drew a parallel line here. So this side, this part of that would be 50. So this part, they have to add up to be 90. This side must be 40. Because they're going to add to be the 90. Because I took the 50 from right there. So, y is equal to 40 squared plus 187.75 squared, and then the square root of that. So the square root of 40 squared plus 187.75 squared is equal to 191.96. So that's what y is equal to. Okay, so this figure right here, we just have to know how to, in our mind, we can only look at certain parts of it at a time. Don't try to look at the whole figure as one great big thing. We're only looking at certain parts of it at a time. First, we only looked at this right triangle right here. The cat's going crazy. We looked at this right triangle right here, and we used the Pythagorean theorem on it to find this side. Then we know that this side from here to here, which is going to be the same as x, is that plus that. So we can find x. Now to find y, we have to make another right triangle right here by eliminating this side, effectively, is what we did. So I drew a parallel line to that one right there, taking off 50 from this side, making that side 40. So then we have another Pythagorean theorem that we can use here. So one little step at a time. Okay, let's see. Well, let's look at, let's do one more little thing here. Let's say that you have, I'm looking at something similar to that's 18. 18 at the top of page 575, where you have a rectangle. Let's say this is a deck or something. It doesn't really matter. Let's say you've got this right here, a rectangular deck. That means all the sides, parallel sides, opposite sides are parallel, and all of the angles are 90. That's what a rectangle is. So let's say, for example, you needed to put a line or something from here to right there. All right, and you need to know how long that distance is. And let's say that your deck is 20 feet wide and let's just say 4 feet deep. Okay, so how do you find that distance from there to there? Well, let's take a look at this right triangle right here, or the other one. There's another one here, right here. This side is 4, and so you would just say C is equal to 4 squared plus 20 squared, and then take the square root of that. So we could say the square root of 16 plus, I think it's, I'm not going to guess, 20 squared, oops, I did a bunch of crap there. Square root of 16 plus 20 squared. There's the, pull out all the even square roots. So that would be about 20.4 feet. So 20.4-ish. All right, so that's, if you just needed to know the distance, you have any rectangle at all, and you need to know the distance from here to here, you can use the Pythagorean theorem. The Pythagorean theorem is one of the most used tools in, certainly in trigonometry, but also in geometry, which is pretty convenient because this class covers both geometry and trigonometry. So the Pythagorean theorem is very heavily used. Just recognize that it's a right triangle, and then recognize maybe you'd be given two of the sides, and you can always find the other one using the Pythagorean theorem.